Hey there, students. I want to give you a look at how to construct a normal quantile plot using data from a problem in my stat lab to construct the normal quantile plot in StatCrunch. So a couple students asked about this problem in particular from our homework set. So I'll use this as an example. It states, use the given data values, a sample of female arm circumferences in centimeters, to identify the corresponding z-scores that are used for a normal quantile plot. Then identify the coordinates of each point in the normal quantile plot. Then construct the normal quantile plot and determine whether the data appear to be from a population with a normal distribution. So this problem is actually giving you 5 data values and then wanting you to go through the steps to construct a normal quantile plot by hand. Like they're having you do the z-scores, then get the points, and then in the third step they ask you to actually make the graph. So I'm going to recommend students just have StatCrunch make the graph for you right up front, and then read all the things that they want from these parts separately off of the graph that StatCrunch made for you. That'll be a lot faster and easier than the way the problem is suggesting that you do it. So I'm going to click on the data here and open it in StatCrunch. And then once it's in StatCrunch, since the normal quantile plot is a graph, I'm going to go to the Graph tab. And the StatCrunch abbreviation for a normal quantile plot on this list here is a QQ plot. So go down to the QQ plot, and that's going to construct a normal quantile plot. So then you select the column that the data is in. It's the only column since you just dumped the data in there. And then the default way that StatCrunch makes a normal quantile plot is slightly different than the way my stat lab shows you their version of the normal quantile plot. But you can make the StatCrunch version match the my stat lab version by selecting normal quantiles on the y-axis. If you select that little box, then StatCrunch will make the normal quantile plot with the same orientation for the axes as my stat lab does. So that's it. Select the column, click this little box here, and hit compute, and you'll get your graph. So here's our picture of the normal quantile plot for these 5 data values. And so just to be clear, what we've done in this graph is the horizontal or x-axis has the values from the data themselves, the data values, and then the y or the vertical axis has the z-scores of those data values, which are the normal quantiles. And for each of the 5 data values, you can hover over the data values point, and it will show you with your mouse, it will show you the z-score, which they refer to as the normal quantile, and the variable value. So for this first lowest point, it has the lowest z-score value and the lowest variable value. And what they want you to do in the problem is list just the z-scores of these 5 points in ascending order from smallest to biggest. So since it's the lowest point on the graph, this has the lowest value, and they want you to round them to 2 decimal places. Round it to 2 decimal places, this is negative 0.97. So I would go over here and I would type in negative 0.97. Then for the next point, I'd go to the next highest point on the list, and the z-score is negative 0.43, so I'll put in that, negative 0.43. Then for this middle point, the 0 is the z-score, so I'll put that in. And then the next point up, I have positive 0.43. And then for the last point, I have positive 0.97. So actually the z-scores are symmetric. The negatives and the positives have the same values, just negative or positive. But you can read each one off of the point in the normal quantile graph that StatCrunch has made for you, instead of doing those by hand. Then they want you to take those z-scores and match them up with their corresponding data values to write down what the ordered pairs would be. And the funny thing is, they want you to write the ordered pairs where the x value is the data value, and the y value is the corresponding z-score, as we have in the graph here. But when you go over a point, they actually kind of list those in the reverse order. They give you the z-score first, and then they give you the variable value. But nonetheless, we can still go through and match them up. So, for example, the lowest value here for the data was 33. You can also see it on the list here. There's only 5 of them. So an ordered pair of the form parentheses xy parentheses, for the first one I would write open parentheses, and then I would write 33, comma, and then the lowest z-score value, which was negative 0.97, close parentheses. So we have to make these points for each of the 5 values that are here. So the next up on the list is open parentheses 34 is the next highest data value. I'm just looking at the list right here. Again, I could hover over the point and see that the variable value is 34. Comma, and then the next z-score was negative 0.43, close parentheses. And the next one, the data value after 34 is 39. And that's the one that had a z-score of 0. And then the next value up is 41. So I'm going to do 41, and the next z-score was 0.43. And then the last one has 44.8 as the data value, and the highest z-score was 0.97. All right, a little bit of a pain to type those in, but it's a lot easier to just get those from the graph quickly, or have the graph make those points for you and then just type them in. So then lastly, we're supposed to make the graph, which we were using all along, and choose from these. And so because we oriented it the same way with the z-scores here and the x values along the bottom, we can perhaps see even from these little graphs which of these looks like it's the closest to being correct. And then choose it from there. So it looks to me, if I look at these values, that D is the closest one. And just comparing it to the graph here. And then finally, the last part is where they ask you to determine whether these data values appear to come from a normally distributed population. In the chapter section, they will go over several examples, and hopefully that'll build your comfort with judging, basically looking at it, whether you think they come from a normal population. I notice here these are pretty close to the line, and so I think because these are pretty close to this line and don't deviate in some systematic pattern, that this is probably from a normal distribution. So I would say yes, and part A says it best. The pattern of the points is reasonably close to a line, so I select that. So there you go. There's a look at how to, given data in a problem in my stat lab, to dump that data into StatCrunch, make a normal quantile plot by going to graph QQ-plot, and then being able to do whatever the problem wants, giving it z-scores or ordered pair coordinates, or pick the graph or whatever. Keep up the hard work, and best of luck.